Imagine standing on a stone-paved road in ancient Greece, watching an entire warship weighing several tons being dragged across dry land by teams of workers, not pushed, not rolled on simple logs, but pulled along grooved tracks carved into limestone, functioning as a primitive railway. In 600 BCE, 26 centuries before the first modern railroad, the ancient Greeks engineered something that sounds impossible: a ship railway that transported entire vessels across a narrow strip of land, saving sailors from a death-defying journey around one of the most treacherous stretches of water in the Mediterranean. This is the story of the Diolkos, from the Greek words dia, meaning across, and halkos, meaning portage machine, a technological marvel that combined the principles of the railway and the overland transport of ships on a scale that remained unique in all of antiquity. To understand why the Diolkos was necessary, you need to understand the deadly geography of ancient Greece. The Peloponnese Peninsula is connected to mainland Greece by a narrow strip of land called the Isthmus of Corinth, just 6.4 kilometers wide at its narrowest point. For ancient sailors traveling between the Ionian Sea to the west and the Aegean Sea to the east, this isthmus presented a brutal choice. Option 1. Sail around the entire Peloponnese Peninsula, a journey of approximately 340 kilometers, 212 miles, that could take weeks. Option 2. Face Cape Malea and Cape Matapan. These two southern headlands were notorious as ship killers. The ancient Greek geographer Strabo captured the terror they inspired with a simple proverb: "But when you double Malea, forget your home." The seas around these capes featured notoriously treacherous waters with variable weather and occasionally devastating storms. Ships were torn to pieces. Sailors were plunged to their deaths. Even Homer immortalized these dangers in the Odyssey. When the hero Odysseus tried to sail through these waters on his return to Ithaca, he was blown off course and ended up in the land of the Lotus Eaters, the beginning of a 10-year odyssey of misfortune. The comic playwright Aristophanes coined the phrase "as fast as a Corinthian," indicating that avoiding this dangerous route had acquired a reputation for swiftness. Clearly, there had to be a better way. Ancient Corinth occupied one of the most strategically valuable pieces of real estate in the ancient world. Located on the isthmus, it controlled both land routes between northern and southern Greece and maritime traffic between two major bodies of water. By contrast to the deadly southern route, both the Gulf of Corinth and the Saronic Gulf were relatively sheltered waters. The overland passage across the isthmus offered not just safety, but also a much shorter route to Athens for ships sailing to and from the Ionian coast of Greece. The Corinthians recognized an opportunity. If they could move ships and cargo across this narrow strip of land, they could control one of the most valuable trade shortcuts in the Mediterranean world. The city grew wealthy and powerful thanks to this vision, but the engineering challenge was extraordinary. Around 600 BCE, during the reign of Periander, the second tyrant of the Cypselid dynasty that ruled ancient Corinth, construction began on the Diolkos. Ancient literature is silent on the exact date, but excavated letters and pottery found at the site confirm this time frame. According to legend, Periander originally considered building a canal. His priests, however, warned that the anger of the two oceans at being mingled would result in the downfall of Corinth. Whether this story is true or not, Periander chose the more pragmatic solution: a paved roadway. The Diolkos stretched between 6 and 8.5 kilometers across the isthmus, making it one of the longest engineered roadways of its time. The trackway was paved with hard limestone blocks, featuring parallel grooves running about 1.6 meters apart. The roadway varied from 3.4 to 6 meters wide. But here's what made it revolutionary. Those parallel grooves weren't decorative. They were functional railway tracks, a guiding system that kept wheeled vehicles from veering off course. The Diolkos was, in essence, a rudimentary railway operating more than 2,400 years before George Stephenson's locomotive. According to Dr. Georgios Spyropoulos, assistant director of the Corinthian Ephyrae of Antiquities, the Diolkos was the first systematic attempt to facilitate the portage of merchandise and warships from the Saronic to the Corinthian Gulf and vice versa. The operation of the Diolkos was an impressive feat of coordinated human engineering. Step 1. Approach and preparation ships would approach via the Gulf of Corinth to the western end of the Diolkos. There was a stone ramp where vessels heading east would arrive. To reduce weight, ships' masts and other movable equipment were removed before the hauling began. Step 2. Initial hauling ships were hauled over a sloping stone-paved jetty, the western end of which was probably underwater using wooden rollers. Teams of slaves and workers used enormous ropes to pull the vessels up the ramps. Step 3. To transfer the vessels were dragged onto a sturdy wooden frame at the top of the ramp. Then, using enormous winches driven by multiple workers, the ships were turned 90 degrees to align them with the Diolkos trackway. Step 4. The journey ships were pulled up another ramp to position them atop iron undercarriages' enormous wheeled platforms that resembled modern freight train carriages. These wheeled vehicles ran along the grooved tracks on both sides, carrying the vessels across the entire isthmus. The gradient of the road increased only about 3%, making the journey manageable despite the enormous weight being transported. The stone's deep grooves guaranteed that the undercarriage and its precious cargo would remain securely on course. Step 5. Relaunch at the eastern terminus near the village of Shoinos, modern-day Kalamaki, on the Saronic Gulf. The process was reversed, and ships were relaunched into the water. The entire operation was a symphony of human strength, animal power, and mechanical advantage-evoking comparisons to the slaves hauling the enormous blocks that built the Egyptian pyramids. For centuries, the Diolkos was lost to history. When Bela Gerster, the chief engineer of the modern Corinth Canal, conducted extensive research on the isthmus's topography in the 1880s, he didn't discover it. The remains were probably first identified by German archaeologist Habo Gerhard Lolling in 1883. Systematic excavations were finally undertaken by Greek archaeologist Nikolaos Verdalis between 1956 and 1962. These excavations uncovered a nearly continuous stretch of 800 meters and traced about 1,100 meters in total. Even though Verdalis's excavation reports continued to provide the basis for modern interpretations, his premature death prevented full publication, leaving many questions unanswered. Today, remnants of the Diolkos still exist next to the modern Corinth Canal, though many sections were destroyed during the canal's 19th century construction. Greek campaigners are calling for greater effort to protect this precious archaeological site. While modern scholarship assumes the Diolkos's primary purpose was commercial cargo transport, ancient historians, always more interested in war than commerce, documented numerous military uses. The Greek historian Thucydides, writing about the Peloponnesian War, recounted the first recorded isthmus crossing in 428 BCE, when Spartans secretly moved their warships across, with all speed toward Athens, avoiding the treacherous sea voyage. This tactical advantage proved decisive in multiple conflicts. Notable military operations. 411 BCE. The Spartans transported a squadron heading for operations at Chios. 220 BCE. Demetrius of Pharos had approximately 50 vessels dragged across to the Bay of Corinth. 217 BCE. Philip V of Macedon sent a fleet of 38 vessels across, while larger warships sailed around Cape Malea. 31 BCE. After his victory at Actium, Octavian, later Augustus, ordered part of his 260 Liburnian warships carried across to advance quickly against Mark Antony. 102 BCE. Rome dispatched Marcus Antonius, grandfather of Mark Antony, whose fleet portaged across to attack Cilician pirates. 868 CE. Byzantine Admiral Nicetas Oriphus had his entire fleet of 100 dromos dragged across in a quickly executed operation, though possibly on a different route. The Diolkos gave whoever controlled Corinth an extraordinary military advantage, the ability to rapidly redeploy naval forces between two seas without the weeks-long circumnavigation. For over 700 years, from approximately 600 BCE until the middle of the 1st century, Diolkos remained in regular service during peacetime, strongly implying commercial viability. Comments by Pliny the Elder and the geographer Strabo described the Diolkos as being in regular service during peaceful times. Little is known about specific trade volumes or toll revenues, but the fact that Corinth maintained this infrastructure for centuries indicates it generated substantial economic returns. The Diolkos may have been particularly valuable for transporting heavy construction materials, marble, monoliths, and timber, coinciding with the rise of monumental architecture in ancient Greece. It's not known what tolls Corinth extracted, but the trackway remained an attractive alternative to the dangerous Cape Malea route for merchant ships willing to pay for the service. The Diolkos' true significance lies in its unprecedented combination of scale and sophistication. Other ancient railways existed tracks for moving stone from quarries, for example, but these served singular purposes over short distances. The Diolkos was different, a multi-purpose transport system operating continuously over millennia, moving diverse cargoes including entire ships. It was open to all vessels upon payment, essentially a toll road for ships, creating a precedent for infrastructure as public utility. The scale on which it combined the principles of the railway and the overland transport of ships remained unique in all of antiquity. For ancient historian Thucydides, writing around 400 BCE, the Diolkos already seemed ancient, a testament to how thoroughly it had become embedded in Mediterranean maritime culture. The Diolkos' decline began in 67 CE when Roman Emperor Nero attempted to build a canal across the isthmus using 6,000 Jewish prisoners captured during the First Jewish-Roman War. Nero personally broke ground with a pickaxe and removed the first basket of soil, but the project was abandoned when he died shortly afterward. However, Nero's canal trenches, dug to a depth of approximately 700 meters, likely damaged portions of the Diolkos' western end. After the 1st century CE, written references to the Diolkos disappear from historical records. Whether it fell into disrepair, was superseded by other methods, or simply became unremarkable enough that chroniclers stopped mentioning it, remains unclear. The dream of cutting through the Isthmus of Corinth never died. Various rulers considered it: Julius Caesar, Alexander the Great, and several Roman emperors after Nero. But the technical challenges remained insurmountable until the Industrial Age. In the 1800s, after Greece gained independence from the Ottoman Empire, the government finally sponsored construction. The Corinth Canal was started in 1882 and completed in 1893, fulfilling a dream more than 2,000 years old. The canal is 6.3 kilometers long, cutting through the isthmus at sea level with no locks. Rock walls rise 90 meters on either side at a near vertical 80-degree angle. It saves ships a 700-kilometer journey around the Peloponnese. However, the canal has significant limitations. At only 24.6 meters wide at sea level, it's impassable for many modern ships. Precarious cliff walls proved prone to erosion and landslides. Strong tidal currents made navigation challenging. Today, it's primarily used by small pleasure craft and tourist cruise boats, ironic, given that the ancient Diolkos may have been more economically successful. The Diolkos offers profound lessons for contemporary engineering. 1. Durability through design. The limestone paving and groove system lasted over 700 years of continuous use, longer than most modern roads survive. Like Roman concrete, which we'll discuss shortly, the Diolkos demonstrates how ancient building techniques sometimes achieve longevity that modern materials cannot match. 2. Appropriate technology. The Diolkos succeeded because it matched available technology to the problem at hand. Rather than attempting an impossible canal, Periander's engineers created a portage system using materials and techniques their civilization had mastered. Modern infrastructure projects often fail by attempting overly ambitious technological solutions. 3. Economic sustainability. The Diolkos remained profitable for centuries, suggesting its fees were balanced against the value it provided. Modern toll roads and bridges can learn from this ancient balance between infrastructure costs and user benefits. The parallels between the Diolkos and Roman concrete are striking. Both represent ancient engineering solutions that modern science is only now beginning to fully understand and appreciate. Recent research published in the journal Science Advances by MIT and Harvard University scientists has revealed that Roman concrete used to build structures like the Pantheon and Colosseum incorporated self-healing capabilities through calcium-rich mineral deposits called lime clasts. For centuries, these white chunks of limestone were considered impurities, evidence of poor quality control. Professor Edmir Mazik at MIT questioned his assumption. If the Romans put so much effort into making an outstanding construction material, following detailed recipes optimized over many centuries, why would they put so little effort into ensuring a well-mixed final product? The answer: those impurities were actually functional features. The Romans used a hot mixing technique, with quicklime a highly reactive form of lime not used in modern concrete. When Roman concrete cracks, water flowing through reacts with these lime clasts to create new calcium carbonate crystals that fill the cracks. The material literally heals itself. When MIT researchers tested this principle, creating concrete samples using both Roman and modern techniques, the results were dramatic. After deliberately cracking samples and running water through them, the Roman-style concrete completely healed within 2 weeks. The lime clasts had triggered a chemical self-healing process. Meanwhile, identical concrete without lime clasts never healed water, just kept flowing through. Why this matters today? This discovery has profound implications for our modern infrastructure crisis. Currently, concrete production accounts for approximately 8% of global greenhouse gas emissions. Creating more durable, self-healing concrete could reduce the need for frequent repairs and reconstruction, lower carbon emissions by extending infrastructure lifespan, create more resilient buildings capable of withstanding climate change impacts, save enormous costs in infrastructure maintenance. Just as the Diolkos offered an ancient solution to the problem of dangerous maritime routes, Roman concrete techniques offer potential solutions to our contemporary sustainability challenges. The Diolkos wasn't the only portage railway in history, though it was the first and longest lasting. The concept was rediscovered in later eras. The Allegheny Portage Railroad, 1834 to 1854. This 36-mile railroad in Pennsylvania used inclined planes and steam-powered windlasses to haul canal boats over the Allegheny Mountains. Like the Diolkos, it eliminated a longer, more dangerous route in this case, connecting Philadelphia to Pittsburgh. The journey that once took 23 days by horse and wagon was reduced to just 3 to 5 days. Charles Dickens called it the wonder of America. Modern slip systems. Today, shipyards and boat lifts use similar principles to the Diolkos wheeled cradles on rails or trackways to move vessels overland. Modern technology has simply mechanized what ancient Greeks accomplished with human power and clever engineering. Standing today where the Diolkos once operated, now bisected by the modern Corinth Canal, it is easy to underestimate what ancient engineers achieved. We live in an age of container ships, high-speed rail, and space exploration. Moving a boat across land seems trivial. But place yourself in 600 BCE. There were no steam engines, no diesel cranes, no hydraulic lifts. The wheel itself was still a relatively recent innovation. Yet ancient Greek engineers conceived, designed, and built a system that would operate successfully for over 700 years. transporting everything from merchant vessels laden with luxury goods to entire war fleets. The Diolkos represents something fundamental about human ingenuity, the ability to look at an impossible problem and engineer a practical solution using available resources. Ancient engineering was sophisticated. The Diolkos, along with Roman concrete, aqueducts, and other ancient infrastructure, demonstrates that our ancestors weren't primitive. They were solving complex engineering problems with remarkable sophistication. We shouldn't assume modern solutions are inherently superior sometimes. The old ways worked better. Infrastructure shapes civilization. The Diolkos made Corinth wealthy and strategically powerful for centuries. It influenced trade routes, military campaigns, and the economic development of the entire Mediterranean region. Today's infrastructure investments, high-speed rail, renewable energy grids, internet networks, will similarly shape civilization for generations to come. Sustainability requires looking backward and forward as we face climate change and resource constraints. We're rediscovering that ancient building techniques often created more durable, sustainable infrastructure than modern methods. Roman concrete that self-heals, stone roads that last millennia. Sometimes innovation means recovering lost knowledge, not just inventing something new. Emperor Nero's abandoned canal project destroyed parts of the Diolkos. The modern Corinth Canal, completed in 1893, obliterated more sections. Greek campaigners now fight to preserve what remains of this archaeological treasure. This raises a poignant question. In our rush to build the new, how much ancient wisdom are we destroying? What knowledge embedded in these ancient stones might help solve tomorrow's problems? The Diolkos operated for over 7 centuries. The modern Corinth Canal, after just 130 years, serves primarily tourists because it's too narrow for contemporary ships. Which was the more successful engineering solution? Perhaps the answer lies in recognizing that ancient engineers like those who built the Diolkos were trying to build for a single generation. They were building for eternity. And in the grooved limestone tracks that still survive after 2,600 years, they succeeded. The next time you see a modern railway, remember, the fundamental concept was proven in ancient Greece, where ships rolled across stone tracks under human power, avoiding death-dealing seas and creating an empire's wealth. The Diolkos wasn't just a portage road, it was a glimpse of future technology built by ancient hands.